Before we look at inverse functions, let's look at reversing things. What's the reverse of yes? Well, hopefully we all know that that's no. What's the reverse of forwards? That's going to be backwards. What's the reverse of multiply by 3? Well, the reverse of multiply is divide, so it will be divide by 3. Let's check that this one works by using a number. I'm going to put 7 in, so 7 multiplied by 3 is 21. If I now put the 21 here and divide it by 3, I get back to the original 7. In the same way, the reverse of add 4 is take away 4. Again, let's check this. 7 add 4 is 11. If I put the 11 in here and take away 4, I get back to the original 7. Now, these are quite trivial examples. This one, though, is a bit more difficult than it looks. I want to know what the reverse of subtract from 20 is. Now, believe it or not, it's actually the same. It's still subtract from 20. Let's prove this again using our number. If we put 7 into this, we've got to subtract 7 from 20, and that gives us 13. Now, if we put 13 into this, we've got to subtract 13 from 20, and that takes us back to the original 7. So the reverse of subtract from is still subtract from. Try to make sure you remember this, because you'll be using it later on in this clip. Now, I've been talking about finding the reverse of something. Another word for this is inverse, and in this clip we're going to be looking at inverse functions. Now, this is a typical exam question on inverse functions. So this is my function of x, and it's telling me that whatever number x is, I've got to put it in here, times it by 2, and add 5. This is asking me to find a function that reverses f of x. And we call this the inverse of f of x, and it's shown using this little -1 here. So I'm now going to show you how to find the inverse of f of x. We're going to do it using a flowchart. So to start, I'm going to show my function of x diagrammatically. So the first thing that happens is x is multiplied by 2. Then we add 5 to it. So if we put x in, we times it by 2 and get 2x, then we add 5 and get 2x add 5. Now we're going to reverse the operations and reverse the flow. So instead of add 5, we've got subtract 5. Instead of times 2, we've got divide by 2. Now if we put x in here, we've got x minus 5. And then divide by 2, so we've got x minus 5 over 2. This is the inverse function. So our inverse function is x minus 5 over 2. And we've just made quite a difficult looking question straightforward by using flow diagrams. Now, I always like to check my answers wherever possible. To do this, I'm going to work out f of x for a number. I'm going to choose 4. So f of 4 is 2 times 4, which is 8, plus 5, which is 13. Now I'm going to put this number into the inverse function, and I should get 4. So I've got 13. 13 minus 5 is 8, divided by 2 does give me 4. So this is definitely the correct inverse function for this. Here's a question for you to try. For the first part, you need to find the inverse function of this using a flow diagram like I've just shown you. For the second part, you need to put 17 into your inverse function to get the answer. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another one for you to try. This one's a little more tricky because it's got an x cubed in it. What you need to remember is that the inverse of cubing is cube rooting. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a very difficult exam-style question for you to try now. For this function here, notice that we've got x, we multiply it by 2, and then we have to subtract from 1. When you're doing this, remember what the inverse of subtract from is. Press pause and have a go. When you're ready for the answers, press play. Here's the answer for part A. For part B, we need to use this part here and this part here. I'm going to take you through this now. To prove that these two things added together equals 0, I need to add this to this. So I've got the inverse function of fx plus the inverse function of gx. That's 1 minus x over 2 from here plus x minus 1 over 2. Now, because they're both over 2, I've got 1 minus x plus x minus 1 all over 2. And 1 minus 1 is 0, and minus x plus x is 0, so that's 0 over 2, which is 0. So I've proved that this equals 0.